Hello students, in last class we discussed about the varactor diode. Today we will discuss about the one of the special purpose power electronic device, silicon controlled rectifier. The name itself we are having the silicon, so we can say the basic material used for the silicon controlled rectifier fabrication is silicon. This silicon is a four-layer P-N device where P and N layers are alternatively arranged. We can observe in this diagram. The outer layers P and N are heavily doped and inner layers N and P are lightly doped. So here we are having the four layers. Due to that four layers, we can form the three junctions named as J1, J2, J3. The three PN junctions are you can observe in the diagram. The outer P layer is called anode and outer N layer is called cathode. The middle P layer is called gate. So we can say silicon control rectifier is a four layer three terminal device. Yes, outer P layer is called anode, outer N layer is called cathode, in middle P layer is called gate. You can observe in the diagram. Yes, anode must be positive with respect to the cathode to make the SCR forward bias. We know anode must be positive with respect to the cathode to make the SCR forward bias. It is similar to our P reactions anywhere. Yes, P-type material must be positive with respect to the N-type material. Then only we can say that is forward bias. Yes, but here forward bias is not sufficient to turn on the SCR. To turn on the SCR, a current is to be passed through the gate terminal named as IGT. It is gate triggered current. Yes. So even when applying the forward bias to the SCR, the gate triggered current must be passed through the SCR. Yes. Then only SCR is on state. Otherwise, SCR is off state. Operation of SCR, we are dividing in two parts. One is when gate is open, that means there is no current passing through the gate terminal. And second one is when gate is closed, when current passing through the gate terminal. First case we are considering when gate is open, that means when gate is open, so we can connect the SCR in forward bias and reverse bias. Yes, how it behaves in this case. First, we are considering the gate is open and SCR is in forward bias, that means anode terminal is more positive with respect to the cathode. Yes, you can observe in the figure A. Here we are connecting the positive terminal of the battery connected to the anode, negative terminal of the battery is connected to the cathode, and gate terminal is open. Due to this, junction J1 and J3 are forward bias and junction J2 is reverse bias. So, when junction J2 is reverse bias, there is a depletion region around the junction J2 and we can observe only leakage current flows through the junction J2 and this leakage current is very small. Yes, practically we can say SCR is in off state. Why? Because junction J2 is in reverse bias, so we can say it is in off state. This is called forward blocking state of SCR, and we apply the positive voltage to anode This voltage is called forward voltage. Yes. In second case, we are considering the gate is open but SCR is in reverse bias. That means anode is negative with respect to the cathode. So you can observe it in the figure B. Even when gate is open, if cathode is made positive with respect to the anode, yes, junction J1, J3 becomes reverse bias. We know. Yes, positive terminal of the battery is connected to the cathode and negative terminal of the battery is connected to the anode. Then we can say it is reverse bias. So due to that, J1, J3 junctions are in reverse bias. When J1, J3 are in reverse bias, junction J1 having the depletion region and junction J3 also having the depletion region. Yes, at junction J1, depletion region inside the N type, that means we are having the positive potential. And similarly, at junction J3, depletion region having the positive potential inside the p-type material. Due to that potential, junction J2 becomes forward bias. So, when gate is open, when you are applying the reverse bias to the SCR, J1, J3 becomes reverse bias and junction J2 becomes forward bias. Still, there is no current flowing. Why? Because junction J1 is reverse bias. Here we are having the leakage current, and junction J3 is also reverse bias. Here we are having the leakage current. In between middle, we are having the junction J2 is forward bias. Yes, outer two junctions are in reverse bias. Middle junction J2 is forward bias. So then we can say leakage current flows in this SCR. It is also very small. Yes, the voltage applied to make cathode positive is called reverse voltage. Now we can say SCR is in reverse blocking state. Clear? So in these two cases we don't have current, we don't have more current in the SCR. So in these two cases we can say SCR is in offset. Yes. Again I am considering if gate is open, when forward bias voltage or forward blocking state, in forward blocking state, forward bias voltage is increasing more, then what happens? When we are increasing the more positive, more forward bias voltage to the SCR, then what happens? Junction J2 is in reverse bias. Due to that more forward bias voltage, the junction reverse bias junction J2 breakdown. Why? Because we are applying the more voltage. So junction J2 breakdown and suddenly large amount of current passing through the junction J2. So SCR conducts heavily. So huge amount of current passing through the SCR. Yes. At which forward bias voltage, junction J2 breaks and SCR conducts heavily is called forward breakover voltage. It is represented with VBO of SCR. In that case, we can say SCR is on state or SCR is triggered. Yes. So this is the first case and second is closed. So here you can observe in the circuit diagram, we are applying the forward voltage to the forward bias voltage to the anode and cathode, positive terminal of the battery connect to the anode, neutral terminal of the battery connect to the cathode, and gate is closed. That means IG current is passing through the gate terminal. So for that gate potential must be positive with respect to the cathode. Yes, then only gate current passes through the gate terminal. The electrons from N-type cathode, which are majority in number. Yes, why? Because cathode terminal is connected to the negative terminal of the battery here, and there also one more battery negative terminal. So due to that, cathode terminal having the majority of electrons in this cathode terminal. Yes, and these are crossing the junction J3 to reach the positive terminal of the battery. The positive terminal of the battery is present at gate side and anode side. Yes, while holes from p-type moves towards the negative terminal of the battery. That means holes from p-type material are moving towards the negative terminal of the battery. That means towards the cathode. Yes, this constitutes the gate current. Yes, electrons are moving towards the gate and some are anode, and the holes are moving from anode and gate are towards the cathode. So it constitutes the gate current. This increases the anode current as some of the electrons cross the junction J2. Yes, when electron crosses the junction J2, we can get the current, anode current. Yes, as anode current increases, more electrons cross the junction J2 and anode current further increases. Yes, so more number of electrons crosses the junction J2, anode current will be increases. Yes, so then we can say SCR is in conduction starts. SCR is in conduction mode. Yes, once gate current passes in the gate terminal, then SCR starts the conduction. Once SCR starts the conduction, the gate terminal loses its control. Yes, so here large amount of current will flow in this because the regenerative action within the short time, the junction J2 breaks and SCR conducts heavily. Yes, so large amount of current passes through the SCR. To limit that, here we are using the resistor, current limiting resistor here. Yes, next one, two transistor model. So in this SCR we are having PNPN 4 layer 3 terminal 3 junction device. So we can make the SCR by using the two transistors. So here it is called two transistor model. In this we are using PNP and NPN transistor. You can observe in the diagram here. The left of is a PNP transistor and right of is a NPN transistor. Yes, the collector current of T1 transistor, that means PNP transistor, becomes base current of transistor T2 NPN transistor, and collector current of T2 becomes base current of T1. Yes, so in this, consider a positive voltage on anode with respect to cathode and gate is open. Yes, gate terminal is open, anode is positive with respect to cathode. So as gate is open, then we can say gate current equals to 0. Yes, that means IB2 is 0. When IB2 is 0 and IC2, current passing through the collector terminal of second transistor, is approximately ICO. Why? Because it is in reverse bias. Yes, when ICO is approximately, ICO is nothing but IC2, it is equals to IC2 equals to ICO, it is equals to IB1. So the base current of T1 transistor is IB1, it is equals to IC2, it is equals to IC. So this is very small, then both transistors are in off state, resulting it offers the high impedance between the collector and emitter of each transistor. Yes, so we can say the anode current is nothing but sum of leakage currents of two transistors, ICO1, ICO2. Yes, now when we apply the positive voltage from gate to cathode, second case we are applying the positive gate voltage from gate to cathode, then what happens? Holes are injected into the base of T2. This forward bias the base emitter junction of T2. So base emitter junction of transistor T2 is forward bias. Then it increases the current IC2. Again, this IC2 is nothing but IB1. This collector current IC2 is the base current of transistor T1. Therefore, it increases the collector and emitter currents of T1 transistor. It reduces the base current of T2 transistor again. Yes, the increase of base current for T2 will result in a further increase in IC2. Yes, so it is nothing but regenerative operation. Yes, the net result is a regenerative increase in collector current of each transistor. Yes, this regenerative process is continuous until both transistors are in the saturation region. That means all the junctions are in forward bias. This results the large anode current, which is limited by limiting resistor R. It is already shown in the previous diagram. Yes. So SCR 2 transistor model is nothing but by using the 1 PNP and NPN transistor, we can make the SCR operation. Yes. We will discuss about the SCR characteristics. Here you can observe the SCR characteristics. These SCR characteristics are dividing into two parts. One is forward bias, other one is second bias. Second one is reverse bias. In the forward bias characteristics, we know the SCR is in forward blocking state, that means forward bias condition. When it is in forward bias condition, we can say junction J1 and J3 are in forward bias and gate is open, I is equals 0. So there is no current flowing through the gate terminal. Yes, in this case, when forward bias voltage increases up to the breaker voltage, SCR conducts heavily because of junction J2 breakdown. So I current passes through the junction J2. It is nothing but SCR turns on. Yes, so you can observe current is passing, voltage increases in the forward blocking state up to VBO. When it reaches to the VBO, sudden high current will passes in the SCR. Yes, even I is equals to 0. Yes, so after reaching the VBO, we are indicating with dotted line. It is nothing but after breakdown. Yes, even I is equals to 0. If gate bias is used, second one, if gate bias is used, then what happens? Gate current increases, less voltage is required to turn on the SCR. So second case, so we are not required to reach the VBO. Yes, before VBO only we can get the current. Yes, when IC current increases, less voltage is required. Yes, that means when gate terminal is closed, so you can get here. Yes, if the forward current falls below the level of holding current IH, here we can identify IH, which is holding current. Holding current is what? It is the value of current below the SCR switches from conduction state to the forward blocking state. Yes, it is the current below which the SCR switches from conduction state to forward blocking state. Yes, in this, when SCR is turned on from off state, the resulting forward current is called latching current IL. You can observe here. It's nothing but latching current is nothing but this is the minimum current flowing from anode to cathode when SCR goes from off state to on state and remains in on state even after gate bias is removed. Yes, once it is triggered, we can remove the gate bias. Then current flowing from anode to cathode. Yes, it is nothing but latching current. Yes, so you can observe here IL and IH is holding current. Holding current is nothing but it is a current. It is the value of current below which the SCR switches from conduction state to forward blocking state. So it is nothing but conduction state to forward blocking state. Latching current is nothing but this is the minimum current flowing from anode to cathode when SCR goes from off state to on state and remains in on state. That means even we can even remove the gate bias. Yes, you can observe here VBO also we are defined. It is the voltage above which the SCR enters conduction region. The forward breakdown voltage is always depends on the gate bias. Yes, in the forward bias you can observe VBO, IL, IH. Yes, so when IG current increases, breaker voltage decreases. That means when gate bias, we can apply gate bias, gate current increases, we require the less voltage to turn on the SCR. That means breaker voltage will be decreased. Yes. Coming to the second part, it is reverse bias. In this reverse bias, that means if anode is negative and cathode is positive, yes, then only we can say SCR is in reverse bias. Then the device enters into the reverse blocking region. We know this one. The current is negligible and it is very small. We can neglect. So it is mentioned here. Yes. If the reverse voltage increase further, similar to the diode, we know what we can say. Avalanche breakdown occurs. So this is called reverse breakdown. Yes. In this reverse breakdown, we can observe the sudden current in the SCR. So it is mentioned like our normal PN junction diode only. Yes. So after reaching the reverse breakdown voltage, sudden current will pass in the SCR. Clear? So here we must observe the forward bias characteristics thoroughly because when gate is open, even we are increasing the more forward bias voltage, after reaching the breaker voltage, what happens? Suddenly junction J2 breakdown and sudden current will passing through the SCR. It is SCR is in conduction mode. Yes, first case. The second case, when we are applying the bias to the gate, that means IG current increases in the gate terminal, the breakover voltage will be decreases and it starts the conduction in the SCR. Yes, here we mention the two currents in the forward bias. One is IH, the second one is IL. IH is nothing but holding current. It is the value of current below which the SCR switches from the conduction state to forward blocking state. Conduction state to forward blocking state. Yes, that is nothing but holding current. Latching current or IL is nothing but it is the minimum current flowing from anode to cathode when SCR goes from off state to on state and remains in the on state even after gate bias is removed. Yes, this latching current is greater than the greater value and it is very closer to the holding current. Clear? And forward breakover voltage nothing but it is the voltage above which the SCR enters into the conduction region. And reverse breakdown voltage is nothing but it is represented with VBR. It is the reverse voltage above which is the reverse breakdown occurs. That is breaking of J1 and J3 junctions. Yes, these are the characteristics of. And what are the applications of SCR? In this silicon control rectifier, in name itself we are having the rectifier, so it can be used in the rectifier circuits, that means control rectifier circuits. Yes, and it can be used as a switch. It's like normal penetration diode, and the silicon control rectifiers are used in the AC voltage stabilizers to provide the constant voltage, and it is a power turn device. Most of the cases these silicon control rectifiers are used in electrical department students, and DC to DC converters that are called choppers or DC to DC boosters, and DC to AC converters are called inverters. We know AC to DC converters are nothing but rectifiers, and DC to AC converters are nothing but inverters. So in the rectifiers and inverters we can use silicon control rectifiers, and electrical students can use for the speed control of DC and AC motors of speed control in the DC and AC motors driver circuits and some protection circuits. Yes, this is about silicon control rectifier. Thank you.